So in this video, I'm going to show you how to use z-scores. Z-scores are also called standard scores, and they're a way for us to think about the proportions or percentages or probability in a distribution of scores or a set of scores. The other thing we can do with z-scores is we can find a particular score or a number of scores if we're given the proportion or percentage of scores. So there's only two questions you really use z-scores for: to find a proportion along that distribution, or to find a score or a number of scores. So let me give you an example. Let's say, for example, we have a nutrition class where we have a number of students who took exam number 1, and we calculated the average on that exam to be 85 with a standard deviation of 10. And we have a student, Marlene, who comes to us and says, hey, I got a 90 on that exam. So her score, her x sub I, is 90. And we want to know like how good that score is, because she's been posting on Instagram and TikTok that she's the smartest person in the class. She's a really, really good student. So the question is how good is this score? Because this score we know is above average, but it could be very, very close to the mean, or it could be very far away from the mean. The first thing we're going to do is just draw what we're interested in. So we always draw what looks like a normally distributed graph here. And then we're going to put in the mean right here where it says 85, and then we'll write the standard deviation below. And then we're going to plot where that score of 90 would be on this distribution. Remember, the scores go from lowest to highest. So that score of 90 would be somewhere around here. Now, just understand that that score of 90 could be right here. It could be right here. We're just putting it above the mean. So if we want to know how good that score is, we might be interested in what percentage of scores, or another way of saying that, what proportion of scores are 90 or better. Think about this. If the proportion of scores that are 90 or better is very, very small, then we should congratulate Marlene of having such a high score. But if the proportion of scores, let's say, that are 90 or better is large, then we might say, well, hey, there's a large percentage of people that did better than you. So step number 2 in answering this question is to calculate z. And the formula for calculating a z-score is z is going to be equal to x sub I minus x bar over the standard deviation. So z is going to be equal to the score, that's going to be 90, minus the mean, which is 85, divided by the standard deviation, which is 10. And if we work that all out, we're going to get a z-score of 5 over 10, or z is equal to 0.50. Now notice what we have here. All along this distribution are x sub i's. These are all of the scores on the exam from all of the students in the class. And for each one of those x sub i's, if we know the mean and the standard deviation, we can calculate its corresponding standard score, or z-score. So what this z of 0.50 means is that when the mean is 85 and the standard deviation is 10, that score of 90 will have a standard score, or a z-score, of 0.50. Also notice that the z-score that always corresponds with the mean is 0. Because if you have 85 minus 85, that's going to be 0, divided by whatever standard deviation, you're going to end up with a z-score of 0. So the z-score that always corresponds with the mean is 0. Also notice that a z-score that corresponds with a score that's below the mean will always be negative. So when you see a negative z-score, that's referring to a score that's below the mean. So z-scores that are positive refer to scores that are above the mean. Z-scores that are negative refer to scores that are below the mean. Now, getting back to our example, how good of this score, we're trying to figure out what percentage or proportion of scores are better than 90. We first drew out what we were interested in. We're interested in this area here. Then we calculated under step 2 what the z-score was for an x sub I, or a score of 90, when the mean is 85 and the standard deviation is 10. Also notice that there are 3 different proportions that we could be interested in here. If I was to draw this arrow here, all of this, from this point here to this point here, would be the proportion of scores that are less than 90. So in this proportion here, it's going to be less than 90. So from this z-score on up is 90 or better, and from 90 on all the way down to the lowest score is going to be less than 90. So we have area number 2 that represents less than 90. We also have area 3 from the z-score to the mean, and we call that mean to z. This area here, because it's the smallest portion, has a name called the small portion. Area number 2, all of this, is called the larger portion because it is the larger portion. And area number 3, from the z-score to the mean, is called mean to z. So we have 3 portions: small portion, mean to z, and then the entire large portion. So what we're going to do is we're going to look up the proportion of scores of whatever area that we're interested in. And we're interested in this area here. Now let me ask you this, Daryl. Is this issue, how about you describe this area? Is it small, large? How might you describe this?
It should be a small area.
Yeah, it's a small area. And all of this would be the large area, right? All of this would be the large area. And this area 3, from the score to the mean, would be from the mean to the z-score. So there's 3 areas, there's 3 areas that we could be interested in: the small portion, the large portion, or mean to z. We're interested in the scores that are better than Marlene's. So we're going to look up here is the small portion. We're going to look up, in this case, the small portion. And the small portion of a z of 0.50, it's going to be very simple to find. So you're going to take your left hand. That's the one when you make an L, we'll say left. Take your index finger of your left hand and put it on where it says z is equal to 0.50. So everybody should have their left index finger on 0.50. Now take your right hand. This is the hand that you eat with. Now take your right index finger and put it on the portion you're interested in, the small portion. So put it on the top of that column that says small portion. Move your right hand down and move your left hand to the right. And when your 2 fingers kiss, you'll see the proportion of scores, or the percentage of scores, that are in that small portion. And that is 0.3085. Does everyone see where I got 0.3085? Now we're going to round that to 2 significant digits, so we're going to call that 0.31. So we're going to write down in our paper that the small portion is 0.31. Another way of interpreting that is, 31% of the scores. So 0.31, 31%. Now we're not done yet. We've done step 3. The 4th step is we're going to write up our results. And this is what I'm going to write. Remember, APA style says you can't begin a sentence with a Roman numeral. So I'm going to say 31% of the class did better than her. This area here is 31%. That means a third of the class did better than her on that exam. She shouldn't be going around saying that she's smart. A third of the class did better than her. Now, is it a good score? Absolutely. But 31% of the class did way better than her. So I go on her Insta page. I type in there, my handle is Dr. Lachos, cool guy number 1. And I'm like, girl, I calculated the standard score and 31% of the class did better than you. You better chill. And then she texts back in a reply, well, what percent of the class did I do better than? Well, that's easy. We could look up the large portion, right? We could look up what this entire portion is. So what do we call that portion, Daryl?
Smaller portion.
No, this portion here. If this is a small portion of
the larger portion.
This is the larger portion. So we're still using a z-score of 50. So we'll put our left hand on 50, but now we're going to put it on large portion. We're going to move our right hand down, and we're going to move our left hand to the right, and you'll see that's 0.6915. We round it to 2 significant digits, so that's going to be 0.69. So 69% of the scores were here. So I could tell her, listen, you did better than 69% of the class, right? But 31% of the class did better than you. Now notice this, Elias. Did we ever need to buy a Haltex to find out what the larger portion was? Why not? Tell us why not. Lead us to the promised land.
Subtract 31 from 100.
Very good. Excellent. You get an A for the day. You can just go home tonight. You're good. No, don't, because you'll miss out on a lot. But yeah, right, because all of this distribution is 100% of the scores. So if you take 69 and you add 31, you're going to get 100%. So we didn't even need to waste our time going in the back of the book. We can just subtract the small portion from 100 and know what this larger portion is. So 69% of the scores did worse than 90. 31% of the scores did 90 or better. Then she might ask us, well, what percent of the scores were between my score and the average score? Teresa, can you tell us what percent of the scores are between mean to Z?
0.19.
0.19 or 19%, right?
19%, yeah.
Yeah, and I know a lot of you guys, you don't know Teresa very well. You don't have the same relationship I have with her. You don't trust her. So if you don't trust her, go look at mean to Z for a Z-score of 50. So you're going to put your right hand on a Z-score of 50, your left hand on mean to Z, move your left hand down, move your right hand to your left, and you can see it's 0.1915. We'd round that to 0.19. But Teresa's so smart, she doesn't even have to go use the back of the book. She just knows that 50% of the scores are above the mean and 50% of the scores are below the mean. So if you take 0.19 and you add 0.31, you're going to get 50%, right? Just like if you took 0.19 and you added 50%, you're going to get this portion and this portion. You're going to get mean to z, and you're going to get mean all the way down to the end of the distribution. So there were 3 steps that we did. The first step was draw it out. Always draw out what you're interested in. Always. From here to the end of time. Draw out what you're interested in. The second step is calculate the standard score. Calculate a z-score. The third step is to look up the proportion or percentage of scores that you're interested in. And then your fourth step is always write up your results. So, I do research in obesity prevention, particularly among children and teenagers. And one measure we have in public health of obesity is something called body mass index. If you're cool, you can just say BMI. So you're out with your friends, after COVID gets over, you're down at TGI Fridays. You can say, oh, I was doing some calculations on BMI. They'll think you're totally cool. So BMI is a measure of somebody's weight status. And essentially how it's calculated, I'm not going to share with you the formula, but essentially it's a ratio between people's height and their weight. So people that are shorter and heavier have a higher BMI. People that are taller and skinnier have a low BMI. Now, a normal weight status is defined as a BMI that would be between 18.5 and, hang on for a second, let me find it, 24.90. Something that's overweight would be a BMI of 24.90 to 30. And then obesity is something that's greater than 30. And then underweight is something that's less than 18.5. And what this does is it gives us a pretty good idea of people's weight status. It's not as good as measuring their percentage body fat or even actually measuring their weight, but it gives us a good idea of what people's body weight or body weight status is, I should say. So I was working on this example last night, and I was telling my wife that I had data from the 2017 Youth Risk Behavior Survey. The Youth Risk Behavior Survey is a survey that the Centers for Disease Control and Prevention conducts every other year, and it asks them questions about health behaviors. How often they smoke pot? Have they ever had sex? Do they use birth control? How often do they eat fruits and vegetables? How often do they exercise? They ask questions about violence, injury. They ask questions about school safety. One of the other questions they ask is they ask the respondents to tell them what their height is in inches and what their weight is in pounds. Now, the YRBS is a study that's conducted among a random sample of about 200,000 students in grades 9 through 12 in public schools all throughout the United States and its territories. So the latest data that I had last night was the 2017 data. And my wife, she's a school teacher now, but she has a master's degree in exercise science and athletic training. So she's like, well, what was the average BMI? She knows what a BMI is. What was the average BMI in 2017 among high school students? And she's teaching high school students now. And I told her that the average BMI was 25.10. So Adriana, how might you describe the weight status of high school students in 2017?
Normal weight, normal BMI.
Well, it's not normal because normal is between 18.5 and 24.90. So this would be, we could say, like one baker's dollar meal above normal. They're overweight, but slightly overweight. Do you understand that?
Oh, it's 25. Okay, yeah, sorry.
So this means that the well, I'm sorry, this should be the average. The average BMI is 25.10. So we might describe that the average high school student is barely overweight, which is true because about 38% of adolescents in the United States have a BMI between 24.90 and 30. In fact, the research that I do in San Bernardino and Riverside County tells me that almost a third of the children and adolescents in public schools in the Inland Empire are overweight or obese. My wife doesn't know about this, but I told her the standard deviation was 5.41. So what does that tell you about how similar or different the scores are among high school students in 2017, Genesis? Are they similar or different? Are they all overweight or are they different?
I want to say that they're different.
Yeah, there's a little bit of variability going on here, right? A little bit of variability going on here. Well, my wife said, like, well, where do I stand in relationship to high school students? Because she's teaching high school students now. She wants to know, like, am I chubbier than the high school students or am I skinnier than the high school students? So I calculated her BMI. And my wife's BMI is 24.40. So how might you describe my wife's weight status, Ashish?
Normal?
Yeah, you better describe it as normal. I'm just kidding. Yeah, it's normal, right? But look, she's like one like trip to 31 flavors away from being overweight. Am I right? So if I wanted to find out how good my wife's BMI is compared to all the other kids, I could find out what percentage of teenagers have a higher BMI than she has and have a lower BMI than she has. All I would need to do is compute a z-score. So Alexis, tell us what the first step is in computing a z-score.
Draw it out first.
Draw it out. So what we're going to do is we're going to draw what looks like a normal distribution. We're going to put in the mean, which is 25.10, and we'll put in the standard deviation, which is 5.41. And then what we're going to do is we're going to plot my wife's BMI along this distribution of scores. So we're going to plot my wife's BMI along this distribution of scores. Rachel, tell me where I should plot my wife's BMI. Tell me when to stop.
Stop.
Right, so 24.40 is probably somewhere around there, right? So if we were to draw a line right here, this area here would be skinnier than my wife, right? This area here, how might we describe this area here, Marlene?
Those that are more than overweight than her, or I mean, not that weigh more than her.
Right. So they're chubbier than her, right? And of course, the mean to z would be the percent that are between my wife and the average BMI. So the second step is we need to convert that x sub I into a z-score. To do that, we'll use the formula z is equal to x sub I minus x bar over the standard deviation. And then we're going to show each step and we're going to plug in our values. The x sub I is 24.40, the mean is 25.10, and the standard deviation is 5.41. If we keep working that out, we're going to get a negative 0.70 divided by 5.41, or we're going to get a z that's equal to a negative 0.129. We're going to round that to a negative 0.13. Now, Jessica knew that this was going to be a negative z-score. She knew that whatever z-score this is, it's going to be a negative z-score. Why did she know that it was going to be a negative z-score, Esteban?
Because it's less or under our mean.
Yeah, because this z-score is representing a score that's below the mean. Any standard score, any z-score that's below the mean will be negative. Because remember, on a normal standardized distribution, the mean is 0. So we've done it. We've done step number 2. My wife wants to know what percentage of the students that year are heavier or chubbier than her. So what's going to be the third step that we're going to do, Michelle?
We're going to look up the score using the table.
We're not going to look up a score. We know what the score is. We're going to look something up, but what are we going to look up? Derek, can you help us out?
Smaller portion?
The smaller portion would be here, right? And that would be the skinnier people. She wants to know what percentage are heavier than her.
Oh, the larger portion.
Right, that's going to be all this, right? From her on up. So that's going to be the larger portion. So we're going to look up the larger portion. So take out your HAL textbook, go to table E.10 that I put in your HAL textbook last night. Take your left hand and put that on a z-score of 0.13, negative 0.13. Put it on negative 1.3. Look for negative 1.3. Isabel, did you find negative 1.3? Yeah, and the reason why you didn't find negative 1.3 is because along the normal distribution, all of the z-scores are absolute values. The only reason we note it as a negative z-score is either because of our calculations or so that we know it represents an x sub I that's below the mean. So you can just use the absolute value of that score. So take your left hand and find 0.13. Take your right hand and go to the large portion. Put your hand on the words, your finger on the words that say larger portion. Move your left hand to the right and move your right hand down. And when your two fingers kiss, you'll see the percentage of scores that are in the larger portion. And what you should see is 0.5517. We'll round that to 0.55. Another way of saying that it's 50% of the scores. Excuse me, 55% of the scores. Any questions how I found the larger portion? Any questions on why I'm looking for the larger portion?
Are we looking at the larger portion because that's what we were interested from the start?
Right, because she wanted to know what percent of the high school kids are heavier than her, right? So it would be all this. Alternatively, I mean, you could ask what percent of the kids were skinnier than her, right? That would be the small portion. So what we know is this whole area here, all the way to here, is 55% of the scores. So I told my wife, I was like, listen, 55% of teens in 2017 were chubbier than you. And then she said 55%. She's like, well, what percent of the teens were skinnier than me? What percent of the teens were skinnier than me? Jackie, what percentage of the teens that year in 2017 were skinnier than my wife?
0.45.
Right, or 45%. Now, there's two ways she figured that out. One way you could figure that out is simply by going to the small portion and look up the small portion for 0.13, for a z-score of 0.13. So you could just look up the small portion of a z-score of 0.13. So if you look at 0.13 and you look at the small portion, it's going to be 0.4483. We could call that 0.45, right? But what Jackie did is she just subtracted 55% from 100% and got 45%, right? Now let me ask you this. Let me ask you this, Jessica. What percent of the students in 2017 had a BMI that was between my wife's score and the average score?
5%?
I'm sorry?
5%?
5%. And how did you figure that out?
The percentage for 50% minus 45.
Right. So you can either do 45 plus this portion would be 50% of the scores, because 50% of the scores are below the mean. Or what you could have done is take 50% and subtract it from 55 and you still would have got 5. Or what's the third way, Alexis, you could have done that? Imagine you weren't good at math. What's the third way you could have done that? Alexis?
I'm sorry.
What's the third way you could have figured out this portion here?
Well, she said 45, or you said 45 plus 5, right? Which would equal 50%.
Right, that's one way. And then another way is taking this larger portion and subtract 55%, which give you 5%. But what's the third way you could have got that?
I don't remember.
Okay, here it comes. This is going to blow your mind. Are you ready for it? I mean, put your seatbelt on. Put your drink down. Facebook all your friends, because here it comes. All you would need to do is go look up a z-score of 0.13 and look at what the mean to z is. And you see it's 0.0517. Do you guys see that? So here's mean to z, here's the larger portion, and here's the smaller portion. But once you know one portion, you can easily find the other two portions. Any questions on how to compute a z-score, how to interpret the z-score? Arsheen's so excited, she's got to hydrate. Okay, cool. Well, I know that was fun, and you're thinking like, could it get any more exciting? Yes, it can get more exciting. Check this out. Let's imagine that we wanted to find what are, or what percentage of scores that year represented a normal weight. So in this case, I have data from the 2007 college risk behavior survey. It's similar to the youth risk behavior survey, but they're asking college students the same question. Now, the last year that the CDC did this was in 2007. Another organization called the American College of Health Assessment took it over. And you can see that data online. But the last year that the CDC did the college YRBS was 2007. And so the question I want to ask is, what percent of college students had a normal BMI? In other words, they had a normal weight status. Well, in this case, in this data, I calculated the average BMI for college students, and it was 23.50. And the standard deviation was 3.40. What you should recognize right away are two things. One, the average college student had a normal weight status. The second thing you should recognize is that there's only a little bit of variability among college students in terms of their weight status. That is, there's not a whole heck of a lot of obese or really, really underweight students. They're all very similar. So what I want to find out is what percent of the college students had a normal BMI? What percent of the college students had a normal BMI? So Ling, what's the first step, Ling, that I would do? Ling Chen, what would be the first step that I would do?
Write to X bar.
I'm sorry?
Can you hear me?
Yeah, I can hear you. Now I can hear you.
First, write X bar.
Write out X bar. I've already written out the mean here.
And
Derek, can you help us out? What's step number 1?
Draw it out.
Yes, draw out what you're interested in. So we're going to draw that what looks like a normal distribution. We're going to put in the mean, which is 23.50, and we're going to put in the standard deviation, which is 3.40. The next step after you put in the mean and the standard deviation is you're going to draw what you're interested in. And remember, a normal BMI is between 18.5 and 24.90. So let's draw in what we're interested in. We're interested in this whole area here. Notice that this area here is the mean. But we're interested in this whole area here. In terms of a BMI, Teresa, what would this area represent?
People that are overweight.
Yeah, overweight or obese, right? Because obese would be way out here, but this would be overweight. And Arlene, what would this represent, this area here, in terms of people's BMI?
It would represent the lower than the BMI, like the lower of the mean of the BMI.
Yeah, what we call that is underweight, right? Or
Yes.
my girlfriend in high school would say flaquita. Do you understand?
Yes.
Okay, so this is underweight, normal weight, overweight, and obese. So we're interested in how big is this portion? Or another way of saying that is, what is the percentage of scores that are between 18.5 and 24.90. Check this out. Step number 2 is we got to compute 2 z-scores. We need to compute the z-score that corresponds with 18.5, and we need to compute the z-score that corresponds with 24.90. We want to know what are these 2 z-scores here. So we need to compute 2 standard scores. So let's compute a z of 18.5. That's going to be equal to x sub I minus x bar over the standard deviation. If we keep working that out, we're going to get the x sub I of 18.5 minus the mean, which is 23.5, divided by the standard deviation, which is 3.40. Now, before we move on here, Nancy, is this going to be a positive or negative score? A positive or negative z-score?
A negative,
Why is it going to be negative?
because the x of I is smaller than the mean.
Right, because this score is lower in the distribution, lower than the mean. Very good. So we'll keep working that out, and we'll end up with a z-score that's equal to a negative 5 over 3.40, or z for an x sub I of 18.5 of a negative 1.47. So we did it. We computed what this score is here. It's a negative 1.47. When the mean is 23.50 and the standard deviation is 3.40. Now we need to calculate the standard score for an x sub I of 24.90. Again, a z of 24.90 is going to be equal to x sub I minus x bar over the standard deviation. We'll keep showing our work, and that's going to be 24.90 minus 23.50. That's x bar, and the standard deviation is 3.40. We keep working that out. We're going to end up with a 1.40 over 3.40. Again, and we know it's going to be a positive z-score because it's representing an x sub I above the mean. So the z-score that corresponds with an x sub I of 24.90 when the mean is 23.50 and the standard deviation is 3.40 is going to be a 0.4117, and we're going to call that 0.41. So we did it. We did step number 2. Madison, what's step number 3?
Step number 3 is to look up the z-score.
Not look up the z-score, but look up the percentage of scores within what you're interested in, right? But this case, we're going to do 2. What we're going to do is we're going to do mean to z here and mean to z here. Because if I add up this portion and this portion, you guys can't see it. If I add up this portion and this portion, I'm going to get this whole portion here. So let's look up mean to this z-score first. So mean to z, right, for a z-score that's equal to a negative 1.47. So if we look that up, we'll see that mean to z, that is going to equal 0.43. Do you guys all see where I got 0.43 in the back of the book, or do I need to show you? And then we'll do mean to z for a z-score that's equal to 0.41. So if you go to the back of the book and you look up a mean to z of 0.41, you'll get 0.1591. We're going to call that 0.16. So here is going to represent 43% of the scores. Here's going to be 16% of the scores. And so if we add up 43 plus 0.16, that's going to give us 59% of the scores. So I can say something like 59% had a normal weight. So let's review how I found that out. I wanted to find out what percent of the students had a normal weight status from the college YRBS. I knew the mean and the standard deviation. The first step as I drew out was I was interested in. I know a normal BMI is between 18.5 and 24.90. So I drew in and I said, I'm interested in all of this. So I calculated a standard score for an x sub I of 18.50, and that was negative 1.47. We knew it was going to be negative because it represented a score that's below the mean. Then I calculated the standard score for the score of 24.90. And then what I did is I found out, well, what is mean to z? What is mean to z for a z-score of a negative 1.47? And what is mean to z for a z-score of 0.41? When I added up those two proportions, it gave me the proportion that was in this area between 18.5 and 24.90, and that was 59%. Now, what if somebody came along, Michelle, and they said, well, what percentage of students were underweight? So I'm going to ask you, what percentage of students had a BMI that will let you know they're underweight? In other words, what's this small portion here?
Are you asking the exact percent?
I'm always asking the exact percent because science is exact, yeah. Susanna, can you help us out?
Is it 33?
33? Why would you think it's 33?
I don't know, because I'm looking at the book.
You're looking at the book?
Yeah.
And where did you get 33 from?
I don't know.
You don't know where you got it from?
Well, I thought you had to look at the like the large proportion and small proportion, right?
What proportion is this? If I was to say this is a pizza and you and your boyfriend were going out to eat, what would this portion be? If he gave you this portion, what kind of portion is he giving you? What would you call that if he just gave you this much? You'd say, hey, you give me the
half?
Half, not half. Can you help us out, Teresa? What would this portion be called?
Small portion?
Yeah, this is a small portion, right? Look at this graph. This is a small portion. If I go out to dinner for my wife and she gives me this much of the entire steak, I'm getting the small portion, she's getting the large portion. But this is certainly not 33%. Rachel, can you tell us what percentage of the students were underweight?
That's the part I've been having trouble understanding.
Okay, Derek, can you help us out here?
Is it 18.5?
It's not 18.5.
Okay.
Unless you're using like George Bush math or something. Can you help us out, Derek? What percentage of students were underweight?
I think it is 16%. 16%.
I would say it's like, well, no, it's not going to be 16%. No, sorry. I was thinking of something else. Nancy, can you help us out?
7%.
It's 7%. Why is it 7%, Nancy?
I subtracted 43 from 50.
Right, because this from mean to the end of the distribution is 50% of the scores. And the mean from this end of the distribution is 50% of the scores. So if all this is 43%, this has to be 7%. Now, if you can't do that math, how could you have found this out, Marlene, if you didn't want to do the math?
I look at the book.
Yeah, what specifically are you looking at? Are you staring at the pretty cover? Are you looking at the introduction?
We're gonna look at the overweight. Well, more on the bigger section.
The bigger section? I want to know this section. What's this section called?
Oh, the lower section. Sorry.
Not the lower section.
The smaller section.
It's not called the smaller section either. I guarantee you. It's called the smaller portion or small portion, right? These have names. Mean to Z, large portion, smaller portion. So let's go look up the small portion of a Z-score of 1.47. Remember, these Z-scores are absolute values. So we're going to go over here. 1.47. And the small portion is going to be 0.0708. We'll round that to 0.07. Do you see the different ways you could find that out? Now let me ask you this, Isabel. What percentage of college students in 2007 were overweight or obese? Isabel, do you know?
66%.
66% were obese. Obese is 24, excuse me, overweight or obese is 24.90 and above for a BMI. So you're saying this area here is 64%? Guys, from the mean all the way to here is 50% of the scores.
Is it 34?
It is 34.
Okay.
This would be 34. Now, if say, for example, you didn't want to do the math, 34 plus 16 equals 50%, how else could you have found that?
In the back of the book. Sorry, I got confused. I thought it was the larger portion, not the smaller.
No, this portion here is the smaller portion. Do you see that? This portion here is the smaller portion for this score here. Do you see that? The larger portion would be all this.
I do now, thank you.
And of course, this would be mean to Z. So if you didn't want to take 16% and subtract it from 50%, you could go in the back of the book and look up the small portion. Or what you could do is you could look up the larger portion, right? You could look up all of this, right? And then you could subtract that from 100 and you'd get 0.34. You're going to get better at intuitively seeing the proportions underneath the distribution as you get more practice. So my expectation is none of you would have got this the first time. Now I know Teresa's showing off and everything, but the idea being here is you're going to have to practice. You got to get it through your head that you're not going to be good at anything in this graduate program the first time you do it. If you're struggling, that tells me you're learning. The people that aren't struggling, those are the people that aren't really learning. So struggling is learning. When you're at home and you're like, I just don't get this. I hate Dr. Lachos. Him and David Howell, they can go on a deserted island and eat crabs all day long. You should be, thank you, Lord, for letting me learn. That is a wonderful thing. Any questions on how to solve a problem like this?
When we obtain the z-scores and we're drawing out our graph, would you like us to write the z-scores back on this drawing that we're doing, or just is it fine if we just have it circled?
I think if you can intuitively understand that what this z-score represents is a standard score when the mean is 23.50 and when the standard deviation is 3.40, this standard score for a score of 18.5 is a negative 1.47. It would always be a negative 1.47. Do you understand that? So if you intuitively understand that, I don't really care what you do because I'm really looking at this. But it's important that you understand that all along here, there are x sub i's. And for every x sub I, there's a corresponding z-score, if you know the mean and the standard deviation. Did I answer your question?
Yes, thank you.
Okay, other questions? Well, I know that was exciting, but we can answer even more exciting questions. Check this out. I've got data from the 2017 Youth Risk Behavior Survey, and it tells me the average age that boys in the United States, teenage boys, will have started smoking is 13.22 years of age, with a standard deviation of 2.48. So that tells me two things. Gosh, the average boy in the United States smokes their first cigarette around 13 years of age, right? But look at the standard deviation. It's also telling me that there's a little bit of variability. Not everybody's 13. In fact, if this was perfectly normally distributed, this would probably be somewhere around 20 all the way down to 7 or 6. So what I want to know is this. At what age will 30% of the boys have already smoked? Smoked a cigarette, that is. At what age will 30% of the boys have already smoked a cigarette? Well, I know the average age for boys smoking, and I know the standard deviation. So let's draw out what we're interested in. That's always the first step. We'll put in the mean, and we'll put in the standard deviation. Now notice that these x sub i's are all going to be lower than 13.22. And all of these x sub i's are going to be x sub i's that are greater than the mean or greater than 13.22 years of age. So what I want to know is at what age will this 30% have already smoked? I want to know what is this x sub I. So am I looking for a percent, Esteban, or am I looking for a score? In a more practical sense, am I looking for a percent or am I looking for an age?
I'm assuming you'll be looking for a score.
Yeah, I'm looking for what this age is, what this x sub I is, right? I want to know at what age will 30% of the boys have smoked. Well, I've already drawn in the lowest 30% of the distribution. So I want to know what this score is. Notice that I'm doing the same thing, but I'm asking a slightly different question. So the second step is to calculate what we're interested in. Well, you know the score for z is equal to x sub I minus x bar over the standard deviation. You know that. You've got it written down. Some of you, when you graduate with your master's degree, are going to get it tattooed on your wrist because you're going to be cool. You might also remember that from your 8th grade math class, or if you went to public school in California, your 12th grade math class, that if you know any of the three in a 4-coefficient equation, you can find the fourth, right? So we know the mean. We know the standard deviation, right? So we know the mean and the standard deviation, but right now we only know 2 of the 4 variables. In order to find one variable, we need to have at least 3 in the equation. Now, is there a way we can find out what this z-score is right here? What the standard score is? Could we find out what that standard score is? We could find out what this standard score is. We could find out what is this z-score that corresponds to this x sub I, even though we don't know what the x sub I is. How do I know we can do that? Because I know this small portion is 30%. What would be this large portion here, Elias?
$70.
70%. Very good. And what would the mean to z be? Let's see. What would the mean to z be, Adriana?
The mean to z from 30%, the mean to z would be 30. I'm sorry.
Mean to
70.
z.
Oh, 20%.
20%. Because 30% plus 20% equals 50%, right? Another way you could have done that is taken 30% from 70%. This is going to give you 20%. So I know this small portion represents 30% of the scores. This is the kids that haven't smoked yet. So if I find out what this x sub I is, I'll know at what age 30% of the boys have already started to smoke. Can I find that z-score? I can find that z-score because I know what the small portion is. I know what mean to z is, and I know what the standard or the large portion is. So all I need to do now is go to the table of the normal distribution, and what I want to find is not what I'm looking for is what is the z-score, but I know the portion in the small portion. So what I'm going to do is look and find a small portion of 0.30. Right now I'm looking for a small portion of 0.30. I'm not looking for a z-score yet. I'm looking for a small portion, 0.30. Let me show you my work again. I'm looking for a small portion, 0.30 or 30%. So Jessica, what is the z-score that corresponds with a small portion of 30%?
0.52.
I can't hear you.
0.52.
0.52?
Yes.
It's not 0.52.
No.
It's going to be a negative 0.52. A negative 0.52. And Elias, why is it going to be a negative 0.52?
Because it's below the mean.
Right, because it's representing a score that's below the mean, so it's got to be a negative z-score. Any z-score for any x sub I that represents a score below the mean is going to be negative. Because if I compute the z-score for the mean, it's going to be 0. So anything below 0 is going to be negative. So now I know what this is. So now that I know 3 of these things, I can plug it in to solve for x sub I. Let me show you how I would do that. So I'm going to take a negative 0.52. It's not a negative 52, it's negative 0.52. That's my z-score for this x sub I is going to be equal to x sub I minus the mean, which is 13.22, divided by the standard deviation, which is 2.48. I keep working that out. By multiplying both sides by the denominator. So if you multiply both sides by the denominator, you can isolate that x sub I. So then what I'll end up is with 1.289 is going to be equal to x sub I and then that's going to be, let's see here, let me see my work here, minus then I'll add 13.22, excuse me, subtract 13 or add 13.22 to both sides. And that will end up with an x sub I of 11.93. Now I knew that this x sub I was going to be smaller than the mean, right? Because it's down here. Like if I calculated this and it was 27, there's no possible way this score could be 27 because this score has to be lower than the mean. Do you guys see that? This score has to be lower than the mean. So what this score is 11.93. That score is 11.93. So my answer is this.
Professor, for future reference, is it okay we just simply did it like this? I don't know if you can see.
I can't see you right now.
Let me bring the computer.
But you want to do it exactly the way that I showed you, okay?
Oh, I just meant like rewriting the formula without, so it wouldn't be so much extra work.
Yeah, as long as I can follow your work, that's fine.
Gotcha.
So what I would say is 30% of the boys will have smoked by age 11.93 years.
I had a question.
Go ahead.
Can you chose the z value of point instead of 0.53? Is it because 0.52 had a closer, smaller portion to 30?
Hang on just a second. So what's your question?
Why the z value was 0.52 instead of 0.53? Is it because the smaller portion is closer to 30 in that number compared to the other one? Because the smaller portion has a difference of, I think, 0.0019 and 0.0015. So then you would pick the one that has the smallest difference, right?
Well, no. If you look in the tabled values, you'll see the small portion. That's 0.3050. That is 0.51. The z-score is 0.51.
Mm-hmm.
But the closest thing to 0.30 is 0.3015, and that z-score is 0.52. You see that?
Okay. Yeah.
You need to be accurate here.
Okay.
Especially when you're using, smaller proportions. When you get bigger z-scores, like in the 3s and the 4s and the 7s, it really doesn't matter. Okay? You have to interpolate anyways. But you do need to be accurate.
Okay. Sounds good. Thank you.
So in this case, notice what we were solving for. We were solving for a score, an x sub I, because we were given a percent. And we're still using that same formula, but how you solve this is you find the z-score that's associated with that proportion, that's associated with that percent. And then once you know 3 of the 4 values, you can solve for the x sub I, solve for the score. You knew that this score was going to be lower than 13.22. It's going to be a score down here. If we would have got a score of 29, you'd have been like, oh crap, I did something wrong. Most likely what you've probably done wrong, Nancy, is you forgot that this was going to be a negative z-score. That's a common mistake that people make. Because here's the thing. If you forget this is a negative z-score, you're actually going to get an x sub I that's going to be greater than 13.22. You've got to remember that any standard score that represents a score below the mean is a negative z-score. Now, I could ask you this. What percent of boys, Rachel, will smoke after age 11.93 years of age?
Uh, 20%, 70%.
Well, which one do you want to choose?
70% of boys.
Right, it's 70% because 30% subtracted from 100% is going to give you 70%, right? And the percent of boys that smoked between age 11.93 and 13.22 years of age is 20%.
Yes, sir.
So there's only 2 questions you ever will answer with a z-score. Ever. Like in the Taylor Swift sense of that word, ever. One type of question is you'll be asked about a percent or a proportion. So one question you might be asked is about a percent or a proportion, like we did here. The other type of question you can solve with a z-score is given a percentage or a proportion, what is that score? Those are the only 2 types of questions you can answer by examining standard scores. You're either going to be 1, given an x sub I and asked for a percent or a proportion, or 2, given a percent and asked what the score is. Those are the only 2 types of questions you can answer with z-scores. Any questions on how to do that? Okay, before we take a break, I want to show you one other thing we can do when we're having fun with z-scores. I told you that I'm a child psychologist. And one of the things that child psychologists are often asked to do, although I don't do this on any regular basis, I haven't actually done one in probably 10 years, is we're asked to diagnose kids for developmental disorder. And a very common developmental disorder among boys is attention deficit disorder. You may have heard of it. One of the ways that I would diagnose a kid with ADD is using something called the Conners rating scale. And there's actually a couple of Conners rating scales that we use. There's one that the psychologist would use. There's one that the parent could use. And there's one that like a teacher, normally a teacher because kids spend the majority of their developmental lives in schools, we'd have a teacher do one. I know that the average kid with, without ADD, their average score on a Conners rating scale is a 150, and the standard deviation is 30. So you can see there's lots of variability in their scores. And this tool's been used for 40 years by psychologists to diagnose kids with ADD. And so we know that the average score on a Conners rating scale is 150 out of all boys. Well, I should say specifically boys between 5 and 18 years of age. And with a standard deviation of 30. In order for me from the DSM to diagnose, the DSM is the Diagnostic and Statistical Manual. It tells us as psychologists what has to occur or what are the diagnostic axes to give a diagnosis for a mental health disorder. The DSM says that a kid has to be in the top 10% to be diagnosed with ADD. So they've got to be in the top 10% of that distribution. They've got to have a score in the top 10% of that distribution in order for me to diagnose that kid. Let's say, for example, I've got a mom that comes to me and says, hey, what would be the score that would be diagnostically meaningful for you to diagnose a child with ADD? So the question is, what is the score that is diagnostically meaningful for children's ADD? What is that score? Well, that's easy to find out. Step one, draw what you're interested in. I know the mean Conners rating scale score is 150 with a standard deviation of 30%. The top 10% is going to be here. So am I trying to find a proportion or an X sub I, Nancy?
Proportion?
No, I'm given the proportion. It's the top 10%.
Oh,
so what am I looking for?
The X sub I.
I'm looking for the score, the X sub I. What is this score right here that marks off the top 10%? Well, that's easy to find. Z is going to be equal to X sub I minus X bar over the standard deviation. I can find out what a Z score is for an X sub I when the small portion is 10%. Another way of saying that is I can find out what a Z score is for an X sub I when the mean to Z, the larger portion is 90% or the mean to Z is 40%. So the Z score that corresponds with a small portion of 0.10 or a mean to Z of 0.40 or a large portion of 0.90, that Z score is 1.28. I only know that because I deal a lot with wanting to know what the top 10% of the distribution is. So I can plug that into my formula. Notice it's a positive 1.28 because it's an X sub I that's above the mean. That's going to be equal to X sub I minus 150, that's the mean, divided by the standard deviation, which is 30. So what I'm going to do is multiply both sides by 30, and that's going to give me 38.40 minus X sub I minus 150. I'm going to add 150 to both sides so I can isolate that X sub I, and that's going to give me an X sub I of 188.40, but for diagnostic reasons we use whole values. So this X sub I here is 188. So what I would say is this: children with a Conners rating scale score of 188 or higher have ADD. So what I wanted to know is, what is the score that corresponds with the top 10% of the distribution? I'm trying to find the score, the X sub I. I can look up what the Z score that corresponds to this X sub I if I know the proportion, either the small portion, mean to Z, or the larger portion. And then if I know 3 of the 4 coefficients in this equation, I can solve for the 4th, and that's exactly what I did. And what I found out is that X sub I is 188. That is the score that would let me know that a kid should be diagnosed. That score or higher should be diagnosed with ADD. Now, if I recall, the last time I did this was like 15 years ago when a kid, and their score was like 223 or something, which isn't actually that high. I've seen in the literature 240s, 250s, 260s, something like that. Because if you think about it, that standard deviation, it can go up. There's probably going to be a score that's at least 240, 250 something. So there's only two types of questions you'll be asked to do. Either one, find the percent or proportion, or two, find the x sub I.